Well, hello everybody, it's Mr. Jeff here, and in this video we're going to talk a little bit about fossils. Now, what is a fossil? Well, a fossil is pretty much just evidence of life. Now, we can't really say just evidence of life though, because that is a very broad statement. So, for example, if we look at these shark jaws. These shark jaws are, yes, in fact, evidence of life. However, they are not fossilized, so it is not a fossil. So it takes a little bit of time for something to become a fossil. On average, it takes about 10,000 years. So paleontologist, which is a scientist that studies fossils, considers anything that is at least 10,000 years old or older that has went through that process to be a fossil. So our definition, you can write this down in your field journals, where a fossil is evidence of life that is at least 10,000 years old. Now, fossils can tell us a lot of different things, like pretty much how it was back then. So if we look at our official whirligig of Earth science history that we have behind me, this tells pretty much the entire scientific history of the planet Earth. Now, if you notice though, all the different time periods are different lengths of time. So for example, if we go to the Triassic period, it lasted 45 million years. But if we go all the way to the Cretaceous, you see it lasted 79 million years. Now, why is that? Why is one period longer than the other or shorter than the other? Now, it's not just because scientists are mean people and then they say this is how long this time period lasted because I'm a scientist and I say so, ha ha ha. No. They determine when one ends and when one begins based off some sort of change. So what that means is 300 million years ago, between the ending of the Carboniferous period and the beginning of the Permian period, something right here changed that made it different. Now we have one of those changes marked out here on the wall. If you look, we have some red daggers. These red daggers represent a very specific kind of change. They represent what's called a mass extinction. Now, mass extinction is when at least 50% of all life on Earth dies out. So something happened at these points in time that caused at least half of everything living on the planet to just die out. So let's count how many times this has happened. We have 1, 2, 3, 4, and then of course 5 all the way at the end of the dinosaurs. The largest one occurring right here at the end of the Permian period, about 250 million years ago. 90% of all life died out. That means that at the end of the Permian period, only 10% of everything that was still alive on Earth was left alive. Something happened right there, some sort of change. And we're going to see if we can use fossil evidence to find out what this change was. Now, the time period that we study a lot here, so for example, if you guys ever go down to Calvert Cliffs, what's the one kind of fossil that everybody's trying to find? That's right, shark teeth. Not dinosaur bones or anything like that, but shark teeth and other sort of marine animal bones. Those come from a time period known as the Miocene, which is all the way up here. The Miocene was about 5 to 20 million years ago. And Calvert Cliffs is the largest collection, has the largest collection of Miocene-era marine fossils in the entire world. So, which means that we can study what it was like in the past based off the fossil evidence. The one fossil everybody's always trying to find is this right here. This is a megalodon tooth. Now, megalodon was a very large shark that lived around here during the Miocene. Now, how do we know that they lived here during the Miocene? Because we find evidence or proof that they were here 20 million years ago. Now, using this fossil, what can we tell about the past? What do you think it was like here? Well, for one, this tooth came from a very large animal. Do we have a lot of deep water around here? No, we do not. So this tells us that 20 million years ago, the water used to be a lot deeper. In fact, where I'm standing right now, 20 million years ago, I would have been under 200 feet of water. Perfect depth for a large shark like this. Now, looking at this, what do you think this animal ate? Was he going after small little guppies? No, he was going after large whales, large animals, because look at the size of that tooth. You can tell what something ate based off the tooth. Now, it didn't always stay like that. because we can tell, looking outside, I'm not under 200 feet of water. But we do have evidence of a change, and that we can see in the fossil record. So for example, we have this nice little fossil right here. This is what's known as coprolite. Now coprolite's a very interesting fossil. It's what's known as a trace fossil. Now a trace fossil is any sort of fossil that shows evidence but is not part of the thing that left it behind. So think of a footprint, a dinosaur footprint. That's what's known as a trace fossil, or any sort of impression left by something. Now what coprolite is actually fossilized droppings. That's what I'm holding, yes. Now this came from a crocodile roughly about 5 or 8 million years ago. Now if we think, where do we think of the habitat of a crocodile or alligators? Usually swamps. Is it a swamp outside? Maybe 2 weeks out of July it's pretty swampy, but not right now. It isn't really a swamp outside. So something changed between the start of the Miocene towards the end of the Miocene. So if you follow me around this way, guys, we'll see if we can discover what that change was. Now you've just traveled back 20 million years in the past. Right behind me we have a megalodon shark. Don't worry, it's not real, it's made out of plastic. Now again, we know that these guys existed around here because we find the evidence that they lived around here. Now how do we know they're this big? We don't find skeletons of sharks because sharks are what are known as cartilaginous fish, which means their bones are made out of cartilage. So everybody feel your ears, feel your nose, that soft stuff. It's what's known as cartilage. It doesn't really fossilize very well, but they do have something in their bodies that does fossilize perfectly. It's nice and solid and hard, and they fall out all the time. That's right, it's their teeth. Now, a large tooth is going to tell us that it came from a large animal. These guys were roaming the seas and oceans around here roughly about 20 million years ago, but then something happened. So if we skip over here, 15 million years after Megalodon, same spot, looks a lot different. You see we have a shallow seashore over here, we have a swamp, we have an alligator over here eating things, making coprolite, and we have this interesting bird over here. This is what's known as a Pelagornis. Now Pelagornis is an ancient seabird that does have a modern living relative today, known as the pelican. Now, speaking of modern living relatives, if we skip back over to the Megalodon real quick, how do we know so much about the Megalodon if they don't exist? Well, we can study modern living relatives. How do we know it has modern living relatives today? By looking at the evidence that we find. If we look at the tooth, we can tell it has sort of a similar shape of a great white shark tooth or a mako shark tooth. So paleontologists believe that they might have a very close relation. So it might have been a very large great white shark, much like Jaws. Same thing with the Pelagornis. It has features on it that are similar to modern day pelicans. So scientists can use pelicans to study the Pelagornis. Now, looking at these two different habitats, environments that we have here, what was the change? Something happened. Well, the Earth goes in patterns. It gets hot, gets cold, it gets hot, it gets cold. Think about it this way. About 100,000 years ago, we were in an ice age. Are we covered under a giant glacier now? No, we're not. So at the end of the ice age, the temperatures started rising and they started to get warmer. At the beginning of the Miocene, it was a lot warmer than it is today. A lot warmer. But then that climate started to shift. The climate was changing. It started to get a little bit colder. As things get colder, especially water, it starts to freeze in the ices in the North and South Pole. So when that happens, the water starts to recede out, and what once used to be a deep, warm, salty ocean is now a shallow seashore with a swamp right behind it. So that's what paleontologists think caused the extinction of the Megalodon, was a massive shift and a change in climate and habitat that also caused its food sources to kind of dwindle out and disappear or move out if they were able to move. Now, if you find that really awesome fossil, okay, Think about it, you're digging in the cliffs, you find a really cool fossil. Are you just going to throw it in the back of your truck and take it home, or take it back to the lab to study it? Well, no, because it's been sitting out in the cold, wet mud for a very long time. So you need something to protect it. And that's when you're going to use a fossil field jacket. So if you guys want to follow me this way, I'll show you an example of it. So this is a plaster fossil field jacket wrapped around this whale skull. Now what the plaster does is that it protects the fossil during transit. So when you're taking it from one place to another, it protects it while you're traveling so it doesn't break apart, because it's very fragile. It's millions of years old. It's been sitting in that muddy cliff for a very long time. Now when we get it back here to the museum, we need to crack it open and take a look at it. So what sort of tools do you think we're going to use? Are we going to use jackhammers? Oh. Are we going to use hammers and chisels? Oh, of course not. We're going to use soft dental tools, and that work is done in our prep lab. Our paleontologists and volunteers use dental tools like this dental toothpick to scrape away at the mud and the rocks and the muck covering the fossils so we can get to the nice bones or teeth underneath or the shells. And all that work, well, a lot of that work is done in here in our fossil prep lab. So this is where the fossils are actually being prepared for either being studied or to be put on display for visitors to come and look at and think they're pretty neat. So if you see in the back, they're working on a what looks like a whale skull. You have a dolphin skull right here. I believe that is a back of a whale skull back there. And a nice dolphin skull up front here. Alright guys, want to thank you for watching this video, and we'll see you in the next one.